Hi everyone, today we're talking about how to find volume involving fractions. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful, make sure you don't fast forward too much that you miss out on something important. So as a review, volume is finding the space inside a 3D prism. So we have to think about, for a prism in particular, it's a 2D shape that's being stretched out. So we're looking at the 2D shape, finding that area, and remember there's tons of that 2D shape being stacked on top of each other. So then to create a shortcut, instead of just adding all those layers, we're just going to take that area and multiply by the number of layers. So that's why the volume of any prism is the area of the base shape, that 2D shape, multiplied by the height of the prism because that tells us the layers. For a cube, it's really just all three of those dimensions, length, width, and height, being added together, and they're the same number, so it's just that number being multiplied by itself 3 times. And notice how there's a square to the third power in your cube, and so that kind of tells you, since there's 3 different dimensions, your unit at the end is also going to be cubed for the 3 dimensions. So here's a picture of that as a reminder. You're taking that 2D shape's area and multiplying by what the height is for the layers. Rectangular prism, it's the length times the width for the bottom 2D shape, multiplied by the height to figure out the layers. For a triangular prism, it's a little different because the triangle is length times width divided by 2, since it's half of a rectangle, but you're also still going to multiply by the height of the 3D shape. So since some people talk about base times height divided by 2 times the height of the prism, you'll see that there's a small h and a big H. So small h is the height of that small 2D shape, just that one 2D shape, and then the big H is the height of the entire 3D shape. So that's how people kind of distinguish between the 2 different heights that we're talking about. You should have this in your notebook, but if you don't, make sure that you have it in there and you're referring back to it to review. Let's go over some examples now. And remember, it's the same as before with the volume, except now we're dealing with fractions. So in this example, they want to know what is the fraction of this rectangular prism. Go ahead and pause the video and try it on your own first. All right, so it's a rectangular prism, so we need to figure out the area of that base shape. That base shape is a rectangle. And then we're going to multiply by the height of the 3D shape, that entire thing. Okay, because that's going to tell us all the layers that go into it. So area of the base, this base is a rectangle, so that's going to be our length times width. The length is 3/4 centimeters, and the width is 1/3 centimeters. And then we have to multiply by the height of the 3D shape, and that's 5/2 centimeters. Centimeters times centimeters times centimeters already tells us that later on our answer is going to be centimeters cubed. So that's all that is. So now we just have to focus on the numbers. These are fractions, so it can be kind of scary, but remember, by multiplying fractions, you're just multiplying across. So 3 times 1 is 3, 3 times 5 is 15. So across is just really 3 times 5, 15, and across on the bottom, 4 times 3 is 12, and then times 2, or what I would do is 3 times 2 first, which is 6. 6 times 4 is an easier multiplication. So with multiplication, you can go in any order. And then now that you're here, you have to reduce it because it looks like 15 and 24 can both be reduced by 3. So this is 5/8 centimeters cubed. Another way you can reduce is you can notice that there's a 3 on top and a 3 on the bottom, and those two will just reduce each other because you have a 3/3, which is the same as 1. So they kind of cancel each other out. It's like multiplying by 3 and then dividing by 3. And then if you canceled those out and multiply, then you just get a 5 on top because both of these become 1s. And then 4 is just left multiplying by 2, which is 8. So by reducing those 3's first, you prevent having to reduce by 3's later on. So either way, it will give you the answer 5/8. And that's it. That's just multiplying fractions. That's as difficult as it gets, is remembering your multiplication rules. So again, you can either multiply across and then remember to reduce at the end, or you can reduce first and you'll have a much easier time multiplying. Either way, same answer. Let's try another one. Okay, go ahead and pause the video. Try this one on your own first. Okay, so again, we have to find the volume. Volume means I have to figure out what the 2D shape is, what the base is. Each of these bases is it looks like it's a square, right? So area of the base shape, that is a square, multiplied by the height of the 3D shape. So if the base is a square, that means both those sides are the same. So you're really doing 1/2 centimeters times 1/2 centimeters. All those sides are the same. So that's side times side, same numbers. And then the height of the 3D shape is actually 3. So let's multiply by 3 centimeters. So there's your formula. Area of the base multiplied by the height, the layers. Centimeters times centimeters times centimeters will give you centimeters cubed. So we're just looking at the numbers now. If it confuses you that there is a whole number, then just make sure you put that whole number over 1. Remember, we're multiplying across. I don't see anything I can cancel out. There's not the same number on the top and bottom, so I'm just multiplying. 1 times 1 times 3 is 3. 2 times 2 times 1 is 4. So 3/4, and remember we have centimeters cubed. So our answer here is 3/4. I hope you got the same, and I hope we're correct. And we are. Let's do one last one before we end for today. Okay. Go ahead and pause the video and try this one on your own. Okay, so we have volume that we need to figure out. It says it's a rectangular prism, but I see all the numbers are the same. So it is a special type of rectangular prism. We've talked about this a couple lessons ago about how the cube is actually a special rectangular prism because squares are actually special types of rectangles. So this is technically a rectangular prism, but it's a special type called a cube, where the rectangle, the base shape, is actually the same as all the sides. So this is a cube's formula. You can still use the general formula, which is figuring out the area of the base, which is a square, multiplied by the height of the 3D shape. The only difference here is the area of the base is a square, so it's going to be the side times the side, And then the height is the same as that side, so it's just going to be that side 3 times. So you're really just doing 2/5 centimeters times 2/5 centimeters times another 2/5 centimeters. Because the area of the base was 2/5 by 2/5, and then the length was also 2/5. So it's just that same number being multiplied 3 times. Centimeters times centimeters times centimeters gives us centimeters cubed at the end. And then for our numbers, we're just going to multiply them across. I don't see any that are matching top and bottom. 2 times 2 is 4. 4 times 2 is 8. 5 times 5 is 25. 25 times 5, it's just like having 5 quarters. Having 4 quarters is 100 cents. And then another extra quarter would be an extra 25 cents. So it would be $1.25 for 25 times 5. So 125. Let's see. I can't reduce that any further, so that looks like that's our answer. 8 125ths. And that's the answer. So that's as difficult as these problems get. And that's because in the real world, not all objects are going to be exactly whole numbers, right? Like you can measure any random object and it's not going to be exact. You're going to have halves, you're going to have fifths, you're going to have fourths. So this is just a way for us to practice how real items in the world function. And that is that they're just not exact. You're going to have to deal with fractions. A lot of carpenters, architects, they deal with fractions because the world is just full of halves and quarters and thirds. Okay? So let me know if you have any questions as you work on these problems, and I'll see you in class.